once again with the quiz number 3 question. So I know that maybe this is confusing, but I'll try to simplify the things for you as much as we can. So basically, this is a question that we had. We do have the allowed stress is going here as 110. If you just follow the example and make it 103, this should be a problem because I can change the Excel sheet very easy, depending on the calculation that you have. Anyway, what we can see here that we're going to have 1, 2, 3, 4 pulleys, but in the force we're going to have only shaft. It's going to be 1, 2, 3, 4, and 5. And just remember, because we are here for a question that's covering the material till week 8, I didn't add the torsion load effects on the calculation of the diameter of the shaft. For the student who attended last week tutorials, you understand that the torque or the shear torsion is going to have an effect on the calculation of the value for the diameter of the shaft. In general, if I'm going to have this shaft, you'll see that we're going to have the following. First, that we putting the torque through the input shafts, and we're going to take them out through the output shaft. It's going to be the same thing for the gears. So for example, this will be the input and this will be the output. So the torque is going to be starting from here and ending down to here. You will see I say, okay, now this one is actually have no torque, no moment. So it's going to be 0. Definitely no, it's going to be 0. Usually in practical life, we consider that the diameter, the minimum acceptable diameter of this point is going to be the same as the point next to it. Okay, so I do have, first I have to remind you about how we did the calculation. So we said that we can, the best tutorial that help you with that is going to be this example we had in week 8 tutorial and the one after. So you are going to make the free body diagram for the part as 2 dimensions like this one. The difference between this one and the question that we had in the assignment was, instead of having the 2 pulleys and 2 bearings, you are going to have 3 pulleys. So it's going to be another pulley here. Then we need to do the sectioning method like that. Okay, so you take the section 1, section 2. I prefer, if I was you, I will take section 3 from here and section 4 from the same side. And by that, we are going to get the value for the bending moments. Showing these steps is going to be a very important thing for the marking. We want to see that you actually did it in the correct way. Okay, after we got all the moments, we sketch the bending moment diagram. Unlike this example, we are not just checking what will be the allowable, the minimum allowable diameter at the maximum point. No, we need to find what will be the diameter at every point. And that's the trick. That's the trick. That's why I added this thing, because simply you find that the moments here and the moments here is going to be 0, but that doesn't mean that the diameter here is going to be 0. We can find diameter here, which is obviously going to be the largest. We can find diameter here, and we can say that the diameter at this point is going to be the same diameter of that point. Diameter of this end is going to be the same diameter of this one. Okay, so we can say that. Because in real life scenario, if you're going to go back to the material for the week number 9, you will find that actually you're going to have the effects of the torque going to give a value for the diameter, and that's what we can see here. So if I'm going to go to the example we have here for the gear, we're going to have multiple gears, multiple torques, and then we start to do the calculation as normal. We found the torque at every point. You will see that we are not going to have 0 torque at any point, except, of course, we're going to have an extension for this one, and we're going to have the bearings. So you can see in this, once again, in the torque, we put an input and we're going to get an output. So for example, this will be input, output, output, input. And the total at the end should be 0. But that means that the point A here does have 250. The point D at the end is going to have minus 150. And by getting this equation, we were able also to find an equation to calculate the minimum diameter as what we had here. Okay. By the way, for this question, this is not the correct torque. That's the correct. I didn't fix that. Yep. Because here, this is wrong value. The RC is not choosing the 0.02 millimeters. We're choosing actually diameter of the pulley. So obviously the diameter of the pulley, which is equal to 150. Okay, so just modify that from your end. Actually, in the copy I showed in the class, I used a different value. So yeah, the diameter, the diameters is going to depend mainly on the torque beside the moment. Okay, now I'm going to show you an example for that. I did participate actually in another subject earlier, and I have in the video that you can find on my channel an example on calculating the diameter. You can see that's step 5, this is step 4, but actually I don't want to go through the video specifically. I just want to show you the example we had. We had this one, we had gear, and 2 bearings in the middle, and we did the calculation to design the shaft. So we start to do some analysis. I don't want to go through what we're doing right here, but in general, that's what we had. Because we're going to have gear, that's we're going to have a thrust force, and we have the axial force. In all the cases, so radial force and the axial force. Thrust force only in case we're going to have the helical gears. So we did the shear moment diagram, and we did the bending moment diagram. And what you can see here that we're going to have also 0 at both ends. And to find the diameter here, we simply just apply another equation, which is more advanced than the one that we show you. So what you can see here that the property of the material defined by the nominal shear stress and the yield stress, the moment and the torque are going to be factors to calculate the diameter. So if this one is going to go to 0, this one is going to have a value, and vice versa. And in worst case scenario, if we're going to have an end with no torque, with no moment, and I think that's what we find in this question, because if I'm going to go back to the diagram, you'll find that the torque is going to be inlet from here and exit from here, and this will have 0 torque, 0 moment. But you will find out that in the calculation later. Okay, point A. Okay, so you can see that we are just adding the parameters. We added some safety factor as well. Again, this is an advanced stage. I don't want you to go through it. I'm just looking at the point D at the end. That's the point C. We have the profile key to be included. Okay, so now to the right of the C, which is the diameter 5, we got the parameter that we have. The moment's already there. We're still at C, by the way. Okay, at point D. So the point D is the seat for the bearing D, and there is no torque or bending moments here. So, however, there's a vertical shearing force equal to the reaction of the bearing. Wow. So we do have another effect that's going to give us the diameter, which is the shearing force. So we can use this calculation. Again, I don't want you to use it right now. Okay, we're going to use this equation to calculate the diameters. You can see that we're going to have the shear force, the KT, which is a safety factor, sorry, the factor for the type of the work we're going to have here, and we're going to have the end value safety factor, and then we can multiply everything and got the answer. That's an advanced stage. Don't worry about it right now. Okay, so I don't know what the other question that we had here. Let me check for the team. I don't want to show the questions of your colleagues here, but let me check what the question I received here today. Okay. Okay. If we assume that the shaft is equal to throughout the D and E, yeah, okay. So we had a question from your colleague, and I think that this video should answer his question. Okay, thank you very much. And if you have any questions, just send it to me. I'll get you more than happy to answer them.